Remember that when we previously spoke about orbitals, we talked about how they were areas of probability where you are likely to find an electron. And darker areas mean that you're more likely to find an electron there. The different orbital types, remember I showed you a picture of, let me see if I can find it. I showed you all of these orbitals, and we'll talk in more detail about them, but we can see that they have different shapes. And I did mention that some of those shapes are due to the need to backfill some empty spaces where electrons could potentially be located. Each of those orbitals has a name. It's a type. So any of the spherical orbitals are called s orbitals, and you're going to need to know that. The ones that are dumbbell shaped or barbell shaped, those are p orbitals. And at the higher energy levels, you're going to see d orbitals. You'll even see f orbitals, which I don't even have shown here, for the really larger, much larger atoms where there's a huge number of electrons in the outer shell. Aufbau's principle tells us that the lowest energy level is always filled first. So that means that we need to know in which order orbitals will be filled. So he actually has this chart, and while I'm going to show you how to use this, I'm also going to show you in class how to figure it out using the periodic table. But first, this way. So the 1s orbital, what this 1 means is that this is the very first layer, the very first energy level, and it's the S-shaped orbital. So that is the orbital that's going to get filled first, and remember every orbital can hold 2 electrons. The next orbital that it gets filled is the 2s orbital, and the way I read this is from the top right to bottom left, where we're following these arrows. So we follow the first arrow down, and then we follow the second arrow down, and what we see here is we go to 1s and then 2s. So the 2s orbital is that circular or spherical orbital that surrounds the 1s orbital. It too can only hold 2 electrons. Okay. Now, what if we have more than 4 electrons? 2 go here, 2 go here. Where are the next ones going to go? Again, we start at the top right and go down to the bottom left. The next electrons are going to go into the 2p orbital. The 2p orbital, remember those are the dumbbell-shaped ones. The p orbitals are the dumbbell-shaped ones, and there are 3 2p orbitals. So since there are 3 orbitals, remember each orbital can hold 2 electrons. Therefore, this energy level, this 2p energy level orbitals, can hold a total of 6 electrons. Okay, so now we have 2 in the 1s, 2 in the 2s, and 6 in the 2p. Now, what if we have more than 10 electrons? Where are they going to go next? They're going to go to the 3s orbital. So again, they're going to go out a little bit. The 3 tells you what level they are, what energy level they're at. And the s tells you what kind of orbital it is, and it's that spherical shaped orbital again. Now, here, again, there's only 1 orbital in the s orbitals. So you've got 2 electrons here. All right, well, what if you have more than 12 electrons in this particular atom? The next place those electrons are going to go is the 3p orbital. Again, p orbitals, there are 3 of them. There's always 3 p orbitals. So at every energy level, you have 3 p orbitals. So here you can hold 6 electrons. And then if you have more electrons than that, you're going to go to this 4s orbital. What I really want you to notice here is that if you continue going, you have many electrons at this point, you're going to start backfilling this third level, this third energy level. So even though you have electrons in the 4s orbital, if you have additional higher energy electrons, they're going to backfill and go into this 3d orbital. Okay. Now, there are 5 different d orbitals. And remember, each orbital holds 2 electrons. So in the d orbitals, they can hold 10 electrons. So 2 in each, and there are 5. So for a total of 10. On this left side, that's actually what this is showing you. This 1s orbital holds only 2 electrons. There's only one orbital, so it's 2 electrons. Again, here's the 2s orbital. That's another 2 electrons. And then you have the 2 p orbitals. And p orbitals always have 3 kind of sublevels. So if they have 3 sublevels, these 3 orbitals can hold 6 electrons. Then you go to the 3s orbital, and again, s orbitals always have only the one sphere where it can hold 2 electrons. And then you go to the 3p orbitals, and that can hold 6 electrons. So 2 in here, 2 in here, and 2 in here. Now, if you have more electrons than that, you're going to go to the 4s, so 2 more electrons can fit here. And then, again, as you go up, you are going up in energy. These are higher energy electrons. So now you can have 10 electrons in this 3d orbital, or this 3d energy level area. We're going to go all the way up to 4f orbitals, and even you can see here it goes down all the way up to 5f orbitals, and 7s and 7p. We're going to use those, but very, very sparingly. I'll show you how to figure out electron configurations using the periodic table. But I really just want you to understand that there are these very three-dimensional areas of probability where electrons are likely to be found, and those are the orbitals. And there's this specific sequence in which orbitals are placed or are found depending on their energy level. So you will be asked to essentially memorize the sequence, but again, in class I will show you an easier way to determine the sequence based on the periodic table so that you do not have to memorize it. Some students choose to memorize it, others do not. I know this is a little bit complicated and certainly very abstract. Feel free to read the suggested pages in the textbook and answer some of the questions. Come to class ready to practice some electron configurations. I'll show you how to figure those out for every single atom on the periodic table, essentially.